Going to sort of okay. So many start में I did a sort of a claim that मेरे ख्याल में structural induction is almost the same as जो induction है original integers के ऊपर, but I'm gonna give you one example of that. Okay, so sorry, how do I hide this? Oh boy. Okay, good. So for example, if you have remember हमने ये कहा था कि for all trees the number of vertices is equal to the number of edges plus one. Okay, और हमने prove किया इसको using structural induction. Okay, let me prove it for you using simple plain classic induction, strong induction. Okay, so what I'm going to do is I'm going to prove it for base case में मेरे पास ये होगा कि I'm proving when the size of vertices is equal to 1. Okay, when the size of vertices is equal to 1, there are no edges possible, which means the number of edges is equal to 0. और इस केस में मेरी condition is true. The base case was simple. Okay, for inductive case, pick any arbitrary tree. Okay, let T be arbitrary. Pick an edge of T and remove it. Okay, मैंने यहाँ पे एक बहुत बड़ी गलती की है, वो ये कि मैंने इंडक्टिव हाइपोथेसिस नहीं लिखा और आपको बताया नहीं कि मैं क्या प्रूव कर रहा हूँ. Let me do this. Okay, so what I'm trying to prove is that for all trees where number of vertices is less than or equal to k plus 1, the statement is true, which is that number of vertices is equal to number of edges plus 1. Okay, ये मेरी assumption है, and I'm going to show this that for all trees the number of vertices is less than equal to नहीं है यहाँ पे. Okay, eraser है मेरे पास, है. Okay, this is probably the first use of eraser I have done this semester. Okay, so when the number of vertices is equal to k plus 1, then I'm going to show that number of vertices is equal to number of edges plus 1. Okay, look at this statement. This is plain old strong induction. I assume the statement is true for something less than k plus 1, for everything less than k plus 1, and then I'm going to show that the statement is true for exactly k plus 1. Do we all agree that this is strong induction? इसमें ऐसा कोई structural induction नहीं है.
Yes, sir.
Okay, as such यहाँ पे हम कोई tree की definition भी नहीं use कर रहे कि tree को हमने construct कैसे किया है. Okay, we are not using any recursive definitions here. So here's the thing. I pick an arbitrary tree. Okay, and I'm going to show that the statement is true for it. Okay, so उसके लिए मुझे ये assume करना होगा कि इसके अंदर number of edges is equal to k plus 1. Number of words is equal to k plus 1. Okay, so let me perform this operation. Remove any edge. Remove any edge. If you remove an edge, what happens? What happens is that your tree divides it into two parts. Okay, at least two parts. Okay, actually exactly two parts में divide हो जाएगा. Okay, एक वो जो इसके ऊपर चीजें थी और एक जो इसके नीचे चीजें. Okay. But the thing is, इस edge को remove करने से इस tree के अंदर, let's call it T1 and let's call it T2. इस T1 के अंदर जो number of nodes हैं, वो original tree में K1 थी, K plus 1 थी. अब वो K plus 1 से definitely कम हो गई हैं. Okay? और same happens here. यहाँ पे भी number of nodes K plus 1 से कम हो गई हैं. Which means कि I can apply my inductive hypothesis now. ओके, सो लेट्स से कि यहाँ पे मेरे पास नंबर ऑफ नोड्स x है, यहाँ पे नंबर ऑफ नोड्स y है. ओके, what I know is that x plus y is equal to k plus 1. Okay, which means that I can write that y is equal to k plus 1 minus x. Okay, so if I know the size of one tree, I know the size of the other tree. Okay, by inductive hypothesis, T2 के अंदर the number of vertices is equal to the number of edges plus 1. Okay, but the number of vertices in here is equal to what? It's x, right? So the number of edges in here is equal to, let me write T2 here, is equal to x minus 1. Okay, so let's count the number of edges in the second part. So by induction, the number of number of words, this statement is true in the second part as well. So y is equal to number of edges in the t1 plus 1. Okay, which means that the number of edges in t1 is equal to y minus 1. Um, what is the number of edges in the original graph? It's equal to the number of edges in T1 plus the number of edges in T2 plus two. Look more carefully. So यहाँ पे कुछ edge होंगे और कुछ edge यहाँ पे होंगे, right? और बाकी edge कहाँ पे होंगे? So let's count these edges and these edges. इसके अलावा बाकी edge कहाँ पे हैं?
इनके सेंटर में.
हाँ, there is exactly one more edge जो हमने delete किया था. Okay? Yes, no?
Yes sir.
So all the edges are in either नीचे वाले tree के अंदर T1 में है या ऊपर वाले में है या फिर ये वाला edge होगा. Okay, so the number of edges in the whole tree is here plus 1. So plus 1. Okay, so let's replace them. Okay, so this is x minus 1, this is y minus 1 plus 1. Okay, but we know that y is equal to k plus 1 minus x. Okay, so let's write it down. X minus 1 plus k plus 1 minus x minus 1 plus 1. Okay, this cancels, this cancels, this cancels, and we are left with k, which is equal to k plus 1 minus 1, which is equal to the number of vertices minus 1. Done. Okay, so we can actually prove the same statement without using structural induction with strong induction in almost all cases. Okay, but the definition of recursive definition of the structures probably makes your life slightly easier. Okay, it tells you कि induction को करना कैसे है. It tells you कि how you are supposed to define a base case and how you are going to do inductive case. Which one do you like? Do you like structural induction or this pure blood classic induction?
Structural induction.
Structure? Yeah, I knew you guys were muggles. All right.
I had a little question.
Sure.
Like for the exam, will we be specified with the type of proof we are supposed to do for the question, or like the question will be open-ended?
So it's possible that you would be told what you are supposed to do. Okay, so it's possible. It's possible that you are not. It's possible that I give you a statement that I ask you just prove it, and the second step is I ask you to prove it using induction, and the third step is I ask you to prove it using structural induction. Okay, so prepare for all scenarios.